Okay, so talking about area here, we have one formula here, our sine formula, 1/2 AB sine C, and this has to do with SAS triangles. Our original formula for area is always 1/2 base times height, and we still use that. We really do, but we have other ways that are faster than always going back to our 1/2 base times height. Now, for this triangle, if I give you 5, 7, and the angle 53, call this A, call this B, and that means this angle has to be C, because side angle B is here, angle A is here, so it's SAS. If it's like this, you just plug into the formula, 1/2 5 times 7 times sine of 53, and that's all just calculator work. The problem is, if they give you a triangle that doesn't fit SAS. If we look at our first problem up here, this was a ASS triangle. So we could not automatically use our rule there. But with a couple of steps, so our first step, solve for B. Is this SAS yet? We don't know this side, do we? So we can't use angle B. But if you go ahead and solve for angle C up here, now we can use SAS. Okay. So if the triangle isn't automatically SAS, you could do some triangle solving so that we do have SAS, and then we can do 1/2. Area for this triangle is 1/2 25 times 22 times sine of 81.53. And that will give you the area of this triangle. So the hard part is that rationale. Which rule do I use? Now, do I have enough information? If I don't have enough information, I can always solve the triangle. It's going to cost me more time. It's going to cost me more work. But this is generally the only way to solve it. We would have to look for our missing parts. Judith, how did that go? Do you need me to do another example?
No, I'm fine, thank you.
Okay, was that helpful-ish?
Yeah, I will.
Okay.
But like on iExcel, there's a question that's asking me for the height. Like, how do I know what?
Sure. The height goes like this. So whenever you have a triangle, you can always pick a flat side. Now, this triangle can be drawn like this. It can be drawn like in a lot of different ways, okay? So the way I think of it as just pick a side that's going to be your flat side. And if I say this is 44, and I give you an angle of 32, and I give you guys, let's give you guys one more side. Let's give you guys 51. No, smaller one. Let's do 36, okay? So the height is going to be this value here, h. So the height could be actually in any direction. It's all about which side do you want to be the base. And if I choose the 44 as my base, sure. If I spun this triangle around and I kind of drew it like this way instead, 32, 36, and 44. See, I spun it around, right? I kind of dipped it over. Fine, 36 could be the base. And then the height would be something else. But the height always involves you drawing this perpendicular line right in the middle here. So if you can do that, that's the height of the triangle. How do you find the height of the triangle? Since we drew a right triangle here, that's just back to solving for your opposite and your hypotenuse. See, that's my opposite, and we know our hypotenuse, don't we? So sine of 32 is equal to opposite over hypotenuse. H is equal to 36 sine of 32. Now, Judith, could I have done the sine formula for solving area for this problem?
Yeah.
Yeah, it's good. Sine, so it goes A is equal to darn it, I messed up here. It's 36 times 44 times 32. Are you cool? That's the formula?
Yeah.
And I can rewrite these around. It's not a big deal. I'm going to show you a crazy trick. 1/2 36 times, that's the rule. Now, if I could find out what h is just 36 sine of 32. Okay, that's the height. If I want to find the area of a triangle, isn't the area of a triangle 1/2 base times height? So Judith, looking at this triangle, what side's the base?
44.
Yeah. Do we have the height? We don't have a number, right? But can you read me this sentence?
36 sine times 32.
It's not sine times, it's sine of 32, okay? It's fine. But the 32 is inside the sine. Now here's the cool part. That's actually our sine formula. Which one was faster? The sine form was faster. But if you want to go back and solve it our geometry way, same exact formula. But to find the height, you always draw a right triangle inside your triangle, and then see what you can do to find out what h is. And that's your height. For the SAT, if you see a triangle that looks like this, call this 5 and call this 10, okay? What's the height of this triangle? Draw the right angle. That's your height right here. And if you guys can see, this is a little harder. You see that you have a right triangle. And that's opposite and hypotenuse. Okay, and that's sine of 32 is equal to opposite over hypotenuse. And that's the height of our triangle. Okay, Osvaldo, what was question number 21 about?
Do I talk?
Yeah, you can.
Oh no, I meant that there's just 21 questions.
Yeah, the 21 questions on review, but the test will only be like 16 or 15 questions.
How about 10?
So when you guys take the review, try to time yourself and see if you can do it in less than an hour and 15. If you can, that means you definitely have enough time to take the regular test.
Mister, how do I solve for a triangle that how do I say this? Okay, so I'm given two side lengths, and I only have one angle, so it's an SAS triangle. Triangle.
SAS, sure.
But I don't know the other two angles, so
So
I need to.
Okay, great question. So let's go ahead and can you tell me? Do you want to share your screen, or I'm just going to draw a triangle? You tell me that's okay. Is this okay for the triangle?
It's a right triangle.
Oh, right triangle.
Mister, I don't know why I can't remember this. I used to be so good.
COVID. COVID. Okay, so what's this side first, if you know it?
It's B.
B, and then what else? This side?
That's C.
Mm-hmm.
And then the other one's A. And then that's angle A. B.
Got it. So tell me what we know about this.
So we know that side A is 6 and side C is 10. And also the angle C is 90 degrees, but we don't know any of the other two angles. Okay, so since this is a right triangle, right, we could find the third side by Pythagorean Theorem. Okay, and that's one of the things that we could do, Pythagorean Theorem. It's a squared plus b squared equals to c squared. And that's always my first thing I'm going to try. Sine, cosine, tangent seems like a lot of work, but if we can do Pythagorean Theorem, why not? 6 squared plus 10 squared is equal, nope, it's my mistake, I'm sorry. 10 is hypotenuse, b squared is equal to 10 squared, 36 equals to b, darn it.
plus b squared equals to 100. Moving the 100 over, that's 64. B has to be 8. Now, my problem now is I don't know any of the angles, and you're right, we don't know how to solve for it. But since it's a right triangle, we have the ability to use sine, cosine, and tangent, and whichever one you want to use. If you want to solve for angle A is opposite, and C is hypotenuse. Which sine, cosine, tangent is opposite and hypotenuse?
You just said it. Tangent.
No,
Which
opposite
tangent
and
is
hypotenuse. No,
Oh,
which
sine.
sine, cosine, tangent? Sine, thank you. Sine of A is equal to 6 over 10. Do you remember how we get rid of sine?
With the inverse.
Thank you, with the inverse, perfect. A is equal to sine inverse of 6 over 10. And that's your calculator answer. Let me take out my calculator. 6 divided by 10 equals inverse sine, shift sine, and I have 36.87 rounding up. Rounding up. If I know this is 36.87, I can find the other side right here. And that's going to be 53, sorry, 53.13. Now I found out all three sides and all three angles. And that's, again, one of the main skills that we're working on, solving for these different types of triangles. It's like I drop 3 sticks on the ground, solve for that triangle.
Thank you.
Of course. What else can help you as well? Oh, here's something that you could also have done. If you were given 6, 10, and a right angle, could you use, let's say we know nothing else but this, could you use law of sines or law of cosines to solve this triangle?
Law of sines.
Law of sines, perfect. As long as you have an angle and a side, law of sines. And this would actually work. So if I have C, I'm going to solve for A, okay? So sine of A over 6 is equal to sine of 90 over 10. And on your calculator, this would totally work. Now, here's something that you might want to know. The sine of 90 is 1. If you guys remember that on a unit circle, the sine of 90 is exactly 1. So sine of A is equal to 6 over 10, which turns out is what we wrote before. And the reason why is sine, cosine, tangent really is back and forth, us doing law of sines or law of cosines or a mix of both. They live in a shared universe. So A, when we solve for it, would still be sine inverse of 6 over 10. Just like what we wrote before, we can use law of sines to solve for this. Okay, what other questions can I help you guys out with, especially on the review?
Want to do the word problem?
Sure, let me go find it.
I could just share my screen.
Sure, that'll be faster.
Somewhere
Let
else.
me stop sharing mine.
Oh, you're sharing.
I know, I'll stop. Okay, go ahead.
Here it goes.
Cool. I'm gonna take a screenshot and I'll take it back over. Thank you. Okay, so for this problem, all right, so, oh, okay. So this one, I picked it on purpose because it looks hard, but it really isn't that bad. It's a bunch of words. But the thing is, for this problem, they drew the triangle for you. They drew the triangle out for you. So they told us one main thing here. If I read it, it says, the path of the satellite is orbiting the Earth because causes it to pass directly over two tracking stations, A and B, which are 43 miles apart. Okay, they're 43 miles apart. Yay. Okay. Then when the satellite is on one side of the two stations, the angle of elevation at A and B are measured at 88.1 and 84.5 respectively. Okay. How far is the satellite from station A? So we're going to look for the right side. And then what is the height of the satellite above the ground? Okay, good. So drawing this out, 88.1 and 84.5. We know this is 43. Right now, looking at this triangle, how many bits of information do we know? 2 or 3?
3.
Trick question? Only 2. Why? Because 88 is not inside the triangle. So we would have to subtract 180 from 88.1. This is from geometry. That's 1, nope, that's not 1. That's 82, 91.9. 91.9? Yeah, now we're good. Now we know 2 bits of information. Can we use law of sines to solve for this problem? Can we use law of sines? Do we have an angle side pair?
Yeah, we do.
So do we know this angle yet?
Yeah,
We could, right? We can find it. How do we find that angle?
180 minus.
180, you're right. So 180 minus 84.45 minus 91 point, let me say, from 9. So we know this angle is this little tiny angle, 3.65. You guys might think this is like irrelevant and who actually does this. But the crazy part, because yesterday I was watching a science video about launching rockets to the space station, and that the Russians did it in like 3 hours the other day. From ground to space station docked, they did it in 3 freaking hours. But they used to do it like in 90 minutes before. So they would take you from the ground into the space station in like 90 minutes. And what happens is there's something called a launch window, and it's literally calculated by what we're talking about right now. Like this math that we're doing is what scientists use to calculate their launch window. It's pretty cool. Sorry, I'm just talking crap. All right, so we're looking for this guy here, side A. All right, so now we have law of sines. All right, that's my angle side pair. So I'm going to use this side now. So A over sine of 84.5 is equal to 43 over sine of 3.65. Okay, give you guys a moment to make sure you guys see what I see. We started off with only knowing 2 bits of information about this triangle. We integrated 88 to become 91. Now we know 3 bits of information about this triangle. 1, 2, 3. We can now try practicing solving this triangle. We decide law of sines, law of cosines. We said if we find the third angle, we have a law of sines. We set up our law of sines. We then solve for A. A is equal to 43 sine 84.5 over sine 3.65. All this is calculator work. Okay, 43 times 84.5 equals divided by 3.65. Ugh. That's a big side. Let's try this one more time. 43 times 84.5 sine divided by 3.65 sine. Yeah. So it's 672 kilometers. Oh, miles apart. Yeah, miles.
I did it and I got like over 2,000 for mine.
Is it? Are you using the same angles as me?
I also got over 2,000, but it was.
Uh-oh.
It was
Let me
with
check my math. Did I mess up someplace?
It was with different numbers, but not that different. Only a couple degrees.
Only a couple of degrees different?
Yeah.
So
This
weird.
would be the answer for both of them, right?
Hmm?
It would be the same for both of them, right?
Same for both of what?
Both the questions, because they're asking, like look at the actual problem. Like there's like 2 questions, and it would.
Oh,
be-
yes. Oh, the second was the height. Second was the height. So the height goes from here all the way down. So let me draw that real quick. The height is that value coming all the way down. Now, we said if we know this is 672.3, let's say 4, and we know this angle is 88.1, we can use sine opposite over hypotenuse to solve it. Let me make sure. Six. Oh, how can I put a 5 here? I don't even know why I put a 5 there. 6. Oh yeah, I don't know why I put a 5 there. That kind of messes this up a little bit. 3.6. Yeah, so this value changed a lot. This is 681 because there was no 5 there.
Wait, so what? Why is it wrong?
For some reason, I wrote a 5 at the end, but there's not supposed to be a 5 at the end. I don't know why. Weirdo. Okay, next question. Okay,
Mister, whenever it asks me to draw out a triangle, should I just assume it's like a right triangle?
no, never assume.
Okay.
I would say when you draw it as a right triangle, it messes you up. Because
Okay,
instead
so
of
then-
thinking of it not, you're like, it must be right.
So then how should I draw it out?
So I use this idea that whenever I'm drawing a triangle, I just make sure I draw the angles that they give me as close as I can as possible. So let's see the problem that they gave you right now. Can you read me the problem?
Solve
Just
the
the angles and
triangle.
sides.
Okay, solve the triangle ABC if B equals 130, C equals 170, and angle B equals 40 degrees.
And which one was the last one?
And angle B equals 40 degrees.
Okay, so 40 degrees is not a big angle, right?
No.
So I'm going to go ahead and just draw this and write 40 degrees. And then I'm going to stick B on the outside. I'm going to say this 170 and then call this 130. So as long as the angle they gave me is small, at least I'm starting off not bad. You could write 170 here, but I actually always like doing it on top. Just my thing. Now, because I drew it this way, angle B and side B, are you okay if this is a ASS triangle?
Sure.
Angle, side, side.
Yeah.
If I wrote 130 here, it'll be side, angle, side.
Mm-hmm.
Okay, this is B. And did they tell you to solve for both triangles or just for one?
It asked me to solve for A, angle A, and angle C.
Did they say if anything was acute or obtuse?
No, it doesn't mention anything about that.
Did they give you a picture? No, right?
No, I have to draw
Okay.
it out myself.
Cool.
It says assume angle A is opposite A, and like that's
Got it.
just a given.
Cool. So this is C, C, A, A. Okay, so we'll solve it for what it is. Sine of C over 170 is equal to sine of 40 over 130. Law of sines. Angle side pair. Law of sines. When you solve for it, it should give you an acute angle. Sine will always give you an acute angle. Unless if they give you a hint that this is the obtuse one, this is going to be acute for us.
Mr. Ko,
Yes.
you know the satellite one?
Mhm.
Something weird happened when I submitted it, and that's that I got the length of side A wrong, but I got the height right, which is weird because you can't get the height without the length of side A.
Then it might be a decimal error.
Yeah, I put it a few times, like with different amounts of decimals. Like I rounded to like the first the hundredths and then the thousandths, and it's yeah, I don't know what's
Let me
wrong.
go
'cause
take a look.
I used the number to get my height, and the height is correct. So I don't
Yeah.
know how the
That is totally weird. Let me take a look. Is this Evan that was talking?
yeah.
Let me see if I can find the assignment. You know what? I can't see your specific question. Can you screen share it?
I think I actually figured out what I did wrong.
What was it?
I think I solved for side when I solved for side B to get the height, but I never solved for side A in the first place. So I put the answer for side B. I get it.
Got it. Yeah,
Can you also do at some point in SSS when it's not
sure. Let's do that then.
right
Law of
angle?
cosines. Do you know which problem that is in the review?
I think it's 11. Let me check. Yeah, it's 11.
Good.
And then it comes back later on like 13 and 14.
Yeah, you're right. 11 is SSS and 13, you're right. Let me go ahead and look at this part. So one example I have is 11, 15, 14, A, B, C. Now for this problem, you notice I have no angle, so there's no angle side pair. So this has to be law of cosine. So to write out cosine, cosine of A is equal to B squared plus C squared minus A squared all over 2BC. Now, because I remember the pattern, I'm not going to ever actually forget the formula. So if I'm looking at angle A, we know we're going to subtract that A squared. So we add the other two sides over 2 BC. So cosine of A is equal to 14 squared plus 15 squared minus 11 squared all over 2 BC, which is 14 and 15. It's the literal sides I just wrote. Now, my hint for solving law of cosines is that I told you guys to actually always solve for the largest angle. If you do that, you'll never end up with an ASS triangle. You will never end up with two versions, always one version. So I'm going to actually solve for C now. Try C instead. Cosine of A, cosine of C. I chose C because the largest side means the largest angle is equal to 11 squared plus 14 squared minus 15 squared all over 2, 11, and 14. Now this is all just calculator work. Now the calculator is really tricky if you haven't practiced this. 11 squared plus 14 squared. And I gotta say this, most of your time on this test will be on the calculator. Divided by parentheses 2 times 11. We end up with 0.29. I want to undo that, and we end up with angle 72. 72.62. Let's do 62. They asked me to round to nearest 10th, so actually just 7.6. Now, if I want to use law of cosines for all three angles, you can. Or I could switch over to law of sines. If I have an angle side pair now, I can switch over to law of sines. Sine of B over 14 is equal to sine 72 point. I'm going to give myself extra decimal just in case. Sine of B is equal to 14 sine of 72.62 over 15. That's all calculator work. Sorry, it's trash day outside. Done. This decimal is not angle. We have to undo it. Rounding up, this is going to be approximately 63 because we're going to round up. 6 pushes the 9 to a 10, forcing a 63. .0 probably. That's how you write it. 63. And then the last one is solving for angle A. Do you guys want me to do law of sines, law of cosines? There's law of cosines here already, right? I think law of sines would now be the fastest way of doing this.
But couldn't you just subtract from 180?
Gosh, you're right. Since you have 2, you can do that. That's even faster. Well done. Who is that?
Me,
Who was me?
Satare.
Oh, good job.
Thanks.
Sorry, you have to hear my voice like twice a day.
What?
You're my TA in like first period?
Me? No.
Oh. I thought you were my TA in one of my classes.
What? No, Mr. Ko. This is the first year I've had you, and I'm only in
Oh.
one of your classes.
Ah. Let me think. Someone else has a name like with an S and a K like yours. Sorry, I haven't taken the time learning how to say your names.
Can you do law of cosines now with
Law of cosines? I just did one.
oh all SSS, right? I don't know why, but I think I know I'm doing it correctly. I don't know why I keep giving the wrong answer.
You want to show me your problem?
No, I'm just kidding.
Go ahead and let me see. Okay. And then, okay, so let me screenshot that. Okay, thanks. All right, guys, we're way past time. So if you want to stay for this last problem, you can. If not, I'll see you guys on the test on Thursday. But I'm going to go ahead and do this last problem.
Bye, Mr.
See you later. Okay, Isabella, which side did you solve for first?
A.
A, okay, let's do A.
I
So
don't know if like,
sine,
I'm putting it into the calculator wrong or something, but
so just FYI, remember, solve for the biggest angle first. That's always the safest one. Okay. Did you remember the 2 on the bottom?
yeah, you would know it's the biggest angle if it has the biggest if it has the smallest side.
No, biggest angle. Look at your fingers. Big angle means big side. Small angle means small side.
So then I should solve for 16 first.
Yeah, that's always the safest one. Because law of sines, if you solve for the wrong one, law of sines will mess you up because it'll give you the acute when you need an obtuse angle.
Interesting.
Yeah, because law of sines cannot solve for angles bigger than 90 degrees. But if your angle's like 100, it'll never give it to you. 12 squared plus
Oh,
16.
that's probably why I kept saying like error or something, like domain error. Is that why it does that?
Right. Yeah. So well, sometimes if it gives you a domain error, if it gives you an error, that means your triangle doesn't exist.
Oh,
It means it totally ripped it apart.
interesting.
Okay. Then undo cosine. You should have got 33 degrees.
Oh, now I'm such an idiot.
What'd you do?
I kept pressing undo side.
Oh, yeah, that's your fault.
Wow, well, I must go. Thanks, Colin.
Yeah, no worries. I'm here to, encourage.
Is there
Oops,
an
I should not record this. All right, folks, we're just playing here. Nothing to see here.
Is there an SAS meeting right now?
Oh, shoot. No, not today. It's every other Tuesday.
Wow, I was gonna